Okay, welcome. We're looking at a couple examples of evaluating functions. What you need to understand is when we're evaluating functions, it's basically, if you're looking at this, wherever the x is basically whatever's in here, you're going to evaluate. This is a function of x, where x over 25 is minus 5. So if you do a function of negative 25, you're basically saying wherever x is in my equation, I'm going to use what's in the parentheses here. So I end up with a negative 25 over 25 minus 5, which gives me a negative 1 minus 5, or a negative 6. It's simple enough. We're plugging in here. And this is just when we're plugging in integers or numbers. This is same thing. Whatever is in here is going to go where my x is. It's a function of x. Now it's a function of 81. So I could just do 81 plus 4, 5 times 9. I wanted to show this too to make sure you guys kind of use your order of operations correctly. And then I have a 49 here. That's a good one. Kind of flying through these. This is why I think we should be able to complete this pretty quickly. This is a good one because we're given a binomial here. So again, what I like to do is, here's a parentheses, z minus 4. So basically I just create the same parentheses where the square was. I'm taking out the a and I'm putting in parentheses z minus 4. And then I get z squared. Negative 4 times c is negative 4z times 2 is negative 8z. That's my little cheat. And then negative 4 times negative 4 is 16. Here's my answer here. Just plugging and solving. Simple enough. This is where I want to show Jordan's problem, because here it's saying a function of, that's q. A function of q is equal to q. So a function of n plus 3 is just simply going to be equal to n plus 3. But we were presented with this problem. A function of x, or a function of height, where x is your input, is equal to 6. Let's not use 6. Let's use 4, because it looks more so like a number. We won't mistake that for a letter. So whatever I put in, my output is always going to be a 4. So if I put in an 8, guess what? The answer is still 4. If I put in a y, the answer is still 4. Because it's basically saying no matter what my input is, my output is always going to be. So if there isn't any, there's just a number, no variable, then we're really not plugging in. It's just whatever that result is the one we're using. And then this is one I saw too. You're just plugging in 2 plus 2, 4 squared 16. I saw that one. And this is another good one I saw. This is probably as tough as they come with this. So again, we're filling in that parentheses for v and putting in and this gives me another opportunity to show my little cheat here. So this, I'm going to square the 3, 9z squared. And how I get this middle number, I do 3z times negative 9, and then I double that. So I get negative 27z, and doubling that, not squaring it, gives me negative 54z. And then I square the last one, negative 9 plus 81 plus 5z plus 3. And we're combining like terms there. 9z squared minus 49z plus 84. I think that's... Say again? I doubled the 27.
Don't you put the equation into the v next to the...
Ooh, good. So we learn through failure, we learn through mistakes. So a mistake that was made is that I forgot to create a parentheses where the 5 was. So really this should be 5 times 3z minus 9, which would have given me a 15z here. let's see, let's just erase that. It would have given me, yes, very good, 15z minus 45, again, plus the 3. So actually, I end up with 39z.
Yeah,
And then
but it's positive.
I think it still remains negative because you have negative 54 plus the 15. And then let's just say 81 minus 40, 41 minus 5, 36 plus 3, 39. So it should have been 9z squared minus 39z plus 39. Hopefully there's no mistakes there. Good catch though, plugging this in. And that's a good mistake we got to see there, and that should be all you need to know to help you with evaluating functions.